Hello everyone, welcome back to second session of module 3, and module 3 the topic is operational amplifier. In the last session I just gave an overview of the whole syllabus. I just repeated for your reference. The syllabus, what you're going to learn in the module 3 is, overall module 3 is about the operational amplifier. In that first topic is the introduction to operational amplifier, operational amplifier input modes, op-amp parameters such as few parameters to name as CMRR, that is common mode rejection ratio, input offset voltage, input offset current, input bias current, input and output impedances, slew rate, gain bandwidth product, and so on. Finally, we'll come to the application of an op-amp. In the application of an op-amp, you have to learn the different types of applications where it can be used as an inverting amplifier, non-inverting amplifier, summer, or the other name is adder, voltage follower, integrated differentiator, and finally the capacitor. In the last session, to recall, in the session 1, we learned about what is an op-amp, the definition of an op-amp, what does the operational amplifier do, how many pin it is, the pin architecture, who invented it, when it was invented, the cross-sectional view, both in the chip form, that is integrated circuits form, as well as when we represent the terms of symbols, how it has been represented and what are the pins of an op-amp. And finally, we just slowly moved on to the block diagram, that is the architecture of an op-amp, and concluded with the advantages and disadvantages of an op-amp and where exactly it has been used. Continuation of the session 1 is now the session 2. What we are going to see in the session 2 is the op-amp input modes. Under the op-amp input modes, you have input signal mode, differential mode, single-ended mode. In the single-ended mode, you have again two different types: single-ended differential mode and double-ended differential mode. Okay, it is the ended modes. Next, finally the common mode, and in the common mode rejection ratio, CMRR. Next, finally the references and the MCQ, as I have discussed in the last time. Okay. In the op-amp input modes, here you have various op-amp input modes, namely one by one we will take. Input signal mode. See, just before going into the types of the input modes, we can see here there is some circuit diagram. In this circuit diagram, we saw last class only, we have seen it is just a symbol where it has non-inverting input, inverting input, pin number 2, pin number 3 respectively, pin number 7 supply, positive supply voltage, pin number 4 negative supply voltage, pin number 6 is the output voltage. How did I get all these pinners? Referring to your last session, we have seen the pin diagram of an op-amp. Now, I told you this operational amplifier basically is to amplify the weak electrical signal which is coming at the input side. How will I give the input here is through the voltage or the signal resistor we are going to use. It pin number 2 or pin number 3 or both. That also can be done. Okay. So the various input modes here are the input signal modes. In the input signal modes, what we are doing is, here how we are going to find is determined by the differential amplifier input stage of an op-amp. Where did the term differential amplifier had come? Differential amplifier concept had come in the session 1 op-amp architecture. In the op-amp architecture, there were 4 blocks. First block was differential amplifier, second block was the high gain, third block was the buffer or the level shifter, and finally the driver block. So 4 blocks. In that first block is a differential amplifier. There the inputs are given. So the input signal modes are determined by the differential amplifier input stage of an op-amp. Next, what is in differential modes means, in the differential mode, either one signal is applied to an input with the other input grounded, or two opposite polarity signals are applied to the inputs. It is not very confusing. I'll just tell you. In the differential mode, either pin number 2 or pin number 3, non-inverting or inverting, can be given. If I give the input voltage to pin number 2, then pin number 3 should be grounded. That is non-inverting terminal, if it is the input is given, inverting to be grounded, and vice versa also. If the input is being given only to minus terminal, that is the inverting terminal, then the non-inverting terminal should be grounded. Or the other way is, I can give voltage level to both also. If I apply the voltage level to both, which has opposite polarity, see here it is plus and minus, then the differential voltages will be taken into consideration. That is called as a differential mode. This type of operation is double-ended operation. That means here, when both the inputs are given together, the difference between input signal is amplified and it appears at the output. Okay. Next, before going into the single-ended mode, I just wanted to stress one point. When an op-amp is operated in the single-ended differential mode, here one input is grounded and a single voltage is applied to the other input. When I told you here, in this I just told you here, one of the input also I can give where other can be grounded. If I give here the input, here it can be grounded, or I can give in both. That represents the single-ended mode. Okay, the diagram here clearly indicates I can give either to non-inverting terminal input means it's given as Vin, where the other terminal is grounded, or I can give to the inverting input Vin where the other terminal is grounded. So this frames the single-ended mode, whereas in differential-ended mode, input is given to both the terminals. Okay, in single-ended mode, it is given to only one terminal. Next, continuing the op-amp input modes, in the single-ended differential mode, here how it is being given means the same thing, just with representation of a signal generator. Where I can give my input voltage is here. The positive of the signal generator should go to the op-amp where the negative should be grounded. If I am going to give the input to the inverting terminal, then non-inverting terminal will be grounded. In the other way, in case if I give the non-inverting terminal the input, the signal generator positive polarity should go to the op-amp and negative should go to ground. See, the signal generator is a device or a component which helps to give the voltage levels to an operational amplifier. And note that operational amplifier is an active component, because this forms the heart of the circuit. So here in the operational amplifier, I can give input to both the terminal or to one of the terminal. If I give to one of the terminal, then it is called as single-ended differential mode. And please note that, or remember that, signal generator positive polarity should be given to the op-amp, whereas negative should be grounded. Similarly here also. Coming to the next type, double-ended differential mode. In the double-ended differential mode, here both the ends, this one signal is been given. When the signal is given to both and we have the same voltage level, say V1 and V2 kept the same, then I can join this. The positive is going here, the positive is going, the negative can be grounded. Okay, that is, I can either connect this way or I can either connect that way. Okay, so what is the takeaway here you're going to get is, the input and the output signals will be in phase for the non-inverting inputs. The word itself represents it's a non-inverting. The input and output signals are 180-degree out of phase if the inputs are given to the inverting terminal. Inverting is minus, non-inverting is a plus terminal. Next, if the input is applied to the inverting input, then you have to check whether the input and output signal are in phase or out of phase. It means like for the input and the output signals are 180-degree out of phase, then it is given to the inverting minus. If the input and output signal voltage are 0-degree and are in phase, then the input signal is given to the non-inverting. This clearly indicates how we are going to get the input and output waveform. I will be showing you in the inverting and non-inverting amplifier when we explain in the further sessions. Okay, so hope this is very clear. Now whatever may be the output, okay, we should have a common mode of voltage. Why the common mode of voltage is there? In the common mode, the same input signal is applied to both the input terminal. Okay, that is called as the common mode. The same input signal is applied to both the input terminal. So the output should remain the same regardless of any common mode voltage. Common mode voltage means here, as we have seen, these two voltages are combined. So it is the voltages are been, these two are been short, and we are going to give the common mode voltage. Okay, remember that the positive polarity should go into the op-amp IC, whereas the negative is grounded. Hope I am very clear what is a common mode. Common mode in the sense, so shorting, inverting, non-inverting terminal. The common wire has to be connected to the positive polarity of this voltage and negative is grounded. Okay, next in the common mode, coming to the common mode, here the two signals voltages of the same phase, frequency and amplitude are applied to the two inputs. Okay, as we have seen here. Okay, when the equal input signals are applied, remember, when equal input signals are applied to both the inputs, then they tend to cancel with each other, resulting in zero output voltage. This action is called as common mode rejection. Its important lies in the situation when we want an unwanted signals which will be when we don't want the unwanted signals which will be appearing during the output. Okay, so then I can use this common mode rejection. It means that the unwanted signals will not appear at the output and the distortion will not appear in the output signals. So you get a undistorted desired signal. That is the use of this common mode rejection ratio. In the common mode, the two signal voltages are of the same phase, same frequency and same amplitude. Remember this. These are the keywords are being applied to the two inputs. When we don't want this distorted or the noise which is occurring externally, then we give the inputs both same voltages, then we short this and we get the when the equal inputs are applied to both inputs, then they tend to cancel, resulting in a zero output voltage. This is called as common mode rejection. Okay, hope I am very clear. These are some of the op-amp input modes. To go in detail, or you want to refer to any references, you can just take these references or any prescribed textbook. Hope this session was very clear and very useful. That is module 3 session 2. We are discussing about the common mode the op-amp input modes. Okay, for further details we can have a 10 questions of MCQ which you give a clear understanding. Say for example, if I tell A741 IC contains what, or what is it named as? It is an operational amplifier, like that. You can have a simple questions. Okay, now this is a few MCQ questions where it based on both session 1 and session 2, which gives a clear questions with the multiple choice answer. And finally, after solving the 10 question individually, you can look into this answer. Okay, the explanation for these answers has been already given during the course of the session 1 and session 2. Hope it is very clear. Thank you.